Hello class, Dr. Vance here, your favorite lecturer. Please, let's continue with our discussions on the Laplace transforms of standard signals. Okay, sorry, it's not exponential. I made a mistake. Okay, so Laplace transforms of what? Standard signals. Okay, so far we have seen unit step, unit impulse, unit ramp. Okay, we have seen complex exponential. Okay, so these are examples of standard signals that we have seen. Standard signals that we have seen. Okay, so now there are also some standard trigonometric signals. So standard trigonometric or signals. Okay, so here let's consider cos omega naught t. Okay, cos omega naught t. Let's consider this particular signal into what? Here u of t. Meaning the signal is starting at 0. So now here x of what? T is equals to cos what? Omega naught what? T into u of what? T. Okay, so now to find this particular signal, we will have to convert it into complex exponential before. Okay, so because we cannot deal directly with this one unless we do convert with complex exponential signal, so that we can have the powers, okay, the exponents interacting. Okay, so here cos omega naught t is actually equals to e exponent j omega naught t, okay, plus, okay, e exponent minus j omega naught what? T. Okay, but you see there's u of t here, so I can bring what here? U of what? T. Okay, all of this one over what? Over 2. Okay, over 2. So why is it actually like this? Okay, let me briefly try to explain to you why they actually have this one. So okay, if we have e j omega naught t, if we should convert this one into trig, we're going to have cos j omega what? Sorry, we're going to have if we have e j omega naught t, if we're converting this one into trig, we're going to have cos omega naught plus j sine omega naught, cos omega naught t plus j sine omega naught t. Okay, then this place also we're going to have plus cos omega naught t, okay, minus j sine omega naught t. Okay, so this is what you're going to have. So in this case, you can see that this j sine omega naught t and minus j sine omega naught t, they are opposite, so they will cancel each other. Okay, what are we going to be left with? We're going to be left with what? This and this. If you add them, you get what? 2 cos omega naught what? T. 2 cos omega naught t. Okay, so you can see that when I expand this one, this is what I get. Okay, but what you can see is that here I have 2 cos omega naught t, but I am looking for what? I am looking for what? Cos omega naught t. In that case, I must divide here by what? 2. Okay, so now you can see that this place, okay, this place is actually, this 2 can actually cancel what? This 2. So that if this 2 cancels this 2, I'll get what? Cos omega naught what? T. Okay, so now if I get cos omega naught t, that means that you see that it is when I expanded this ones, that is when I got this one. Okay, so that is why they're saying that whenever you have this one, you can also write it in this particular format. All right, so it becomes that what? Simple. Okay, so knowing this, I think we can just move on from here. Okay, we can just move on from here. Okay, so now moving on from here, what I can say is that x of what? T is equals to, I can bring this 1.5 out, so that I can have 1.5 into what? E j omega naught what? T. Okay, into u of what? T plus e minus j omega naught t into u of what? T. Okay, into u of t. All right, I can close my bracket this way. Okay, so now if I am taking the Laplace transform of of this one. If I'm taking the Laplace transform of this one, so let me say that LT of what? X of what? X of t. Okay, then it's going to be what? Infinity. But here you see that I have what? Ut, meaning that the signal is starting from what? 0. It's starting from 0. So I can say that 0 to what? Infinity. 0 to infinity. And then what I can say now is that is ej omega naught what? T plus what? Minus ej omega naught what? T. Okay, into e minus what? St the what? The t. Okay, so this is what I can say from here. Okay, so now if I am going to find the Laplace transform of this one, okay, let me just break it down for you. So I can have 0 to what? Infinity. Okay, e j omega naught what? T into what? E minus what? St. Okay, plus what? 0 to what? Infinity. E j minus omega naught what? T into e minus what? S what? St. Okay, so if I break it into two, this is basically what I'm going to actually get. Okay, so now if I have this one, you just deal with this place. Okay, you deal with this place, and this place you're going to have 1 over S minus j omega naught what? T for this place. This place you're going to have what? 1 over what? S plus what? J omega naught what? T. Okay, but all along, please, this half, okay, we have to bring this half. We don't have to forget about it. Okay, so we can just put our half here. Okay, so here I just have to all right, let me not do anything here, but let me just put half here, and let me put half what here. So basically this is what I'm saying. A Laplace transform. Okay, let me cancel it. Okay, Laplace transform of what? X of what? T. Okay, here will be, if I bring this half out, so half, okay, I'm going to have 0 to what? Infinity. Okay, e j omega naught what? T. Okay, into e minus what? St. Okay, plus, okay, 0 to what? Infinity. E minus j omega naught what? T into e exponent minus what? St. Okay, so basically, and then I can close it. Okay, so basically it's like this. Okay, so now if I want the Laplace transform of this, what do I get? If I want the Laplace transform of this, what do I get? I mean, that becomes very simple. Okay, from our previous discussions, you can just write out one word straight away. Okay, so we can just write that one straight away. So now, if I want the Laplace taking Laplace transform of this one, what I'm going to get is that I'm going to get 1 over what? 2 into this place. This place, I'll get 1 over what? S minus j omega naught. Okay. Then I'm going to have this place. Okay. So this plus will come. So plus. Here I'm going to have 1 over what? S plus. Okay. So S plus j omega what? Naught. Okay. So this is what I'm going to have. Alright. So now, if you want, you can just expatiate. Okay, you can just expatiate on this one. Okay, so if you should expand this one, okay, if you should expand this one, what are you actually going to get? Okay, so if you want to expand this one, you can say that x of what? S is equals to here you can have what? S plus what? J omega what? Naught. Okay, wait, half before half. Okay, plus what? S minus what? J omega what? Naught. Okay, alright. So basically, this will cancel this. Okay, like this. And then here, this into this. Okay, and then this into this. You get what? S squared. Okay, plus what? Omega naught what? Squared. Because this into this, S squared. This into this, negative. This and sorry. This into this, S squared. This into this, positive. This into this, negative. This into this, omega naught squared. Okay, because omega naught is what? Omega naught squared. Negative j into j is what? Negative what? 1. And then there's another negative here, so it become what? Positive. Okay, so that's what you get. So now here, this will cancel here, and you have s over what? S squared plus what? Omega naught what? Squared. Okay, Laplace what? Transform for this one. Okay, so this becomes the Laplace transform for this one. All right, and then so what I can say is that cos omega naught what t has a Laplace what transform, okay, of s over what s squared plus omega naught what omega naught what squared, omega naught squared. Okay, and here the ROC. What is the ROC? The ROC is such that real of s is greater, okay, greater than 0, because what you see is that the function here is u of t. U of t, t is equal to 0. U of t will lie in the positive axis of the x-axis. Okay, so that means that u of t is greater than what? 0. Okay, so here is greater than what? 0. So this is for this one. All right. So let's do another one for sine. Okay. So as for the sine, we're going to be very fast because now we're quite familiar with the process. Okay, with the process. Okay. So now here, if I have vi, okay, if I have x of what? T to be equal to what? Sine omega naught what? T. Okay, x of t is equal to sine omega naught t. How can I find the Fourier transform into u of what? T. Okay, so now the Fourier transform of this one, sine what? Omega naught what? T into u of what? T. Okay, so x of what? T is equals to this. Okay, so sine omega naught t is actually, if you should expand it in terms of complex exponential or in terms of exponentials, exponential functions, okay, you're going to get e j omega naught what? T. Okay, minus e minus what? J omega naught what? T. Okay, over what? Over 2j into u of what? T. Okay, so this is what you're going to get. Okay, if you want to know why we got this one, you can just follow my earlier example on the course. Okay, on the course, or briefly I can just show you that if you want this one, you have what? Cos omega naught what? T. Okay, plus sine omega naught what? T. Okay, if you want this one, you're going to get minus what? Cos omega naught what? T. Okay, and then you will get minus sine, sorry, here is j, minus j sine omega naught what? T. Okay, so this is what you're going to what? Get. So if you should expand this, you get what? Cos omega naught t plus j sine what? Omega naught what? T. And then you're going to get minus cos omega naught what? T. This time this is minus. And then you're going to get what? Plus j sine omega naught what? J sine omega naught what? T. Okay, so this one and this one, they are opposites, so they cancel each other. This one and this one, you get what? 2j sine what? Omega naught what? T. Okay, that's what you get there. Okay, so now if you have 2j sine omega naught T, but you are looking for what? Sine omega naught T, then you have to divide it by what? By what? 2j. So if you divide it by 2j, 2j will cancel 2j, so that you get what? Sine what? Omega naught what? T. So you see that when I expand this one, this is what I get. So that's how come they are saying that if you have this one, then you should write this one. Okay, so now I can just write it. X of t, which is equal to what? Sine omega naught what? T into what? U of what? T is equals to what? Is equals to e j omega naught what? T minus e minus j omega naught what? T. Okay, here into what? U into u of t. Okay, into u of t. So here, please let me bring the u of t so that I can bring my u of t here. Okay, so that I can bring my 2j here. Okay, so if we should expand, then if we should expand this one, then we're going to get sine omega naught what? T into what? U of what? T is equals to e j omega naught what? T into u of what? T minus e minus j omega naught what? T into u of what? T. Okay, all over what? 2j. Okay, so this is what I'm going to get. So now, if I have this one, basically, just like the way I did the other ones, you can just do it straight away. Okay, so what you can do is you can, if you want the Fourier transform of this one, you want the Laplace transform of this one of x of what t, then you're going to have summation. So you see that the signal is what, u of t, starting from what, 0. So I have 0 to what, infinity. I have 0 to infinity. If I have 0 to infinity with respect to this signal, I can bring 2j out. So 1 over what, 2j. That can come out, okay? So if that one comes out, then here I'm going to have e, okay, ut is 1. So ut is 1, so I can ignore it, okay? So ej omega naught what, t, okay, minus e minus j omega naught what, t, okay, like this, into what, minus what, st, okay, d what, dt. Okay, so with respect to Laplace transform, this is what I can have, okay. And then if I have this one, then it's equals to 1 over what, 2j, okay, 2j into what, here 0 to what, infinity. I have ej omega naught what, t, into e minus what, st, okay, minus, okay, this minus, okay, here 0 to what, infinity, e minus j omega naught what, t, into e minus what, st, okay, d what, dt. Here I can bring dt. Okay, so basically this is what I have. Okay, and then if I have this one, what I can get is here I can have, if I'm going to do, I can just do the integration for this one, okay, or I can just find the Laplace transform straight away for this one, okay. So here the Laplace transform, if I'm taking the Laplace transform, I'm going to have x of s is equals to what, 1 over what, 2j into what, here I'm going to have 1 over s minus j omega naught t, okay. So I'll have 1 over s minus j omega naught what, t, okay. Or you can go through the integration and then introducing your limits and then finding it, okay. You come to the same answer as I'm writing right now. And then here I'll have this minus will come here, and I'll have 1 over what, s plus what, j omega naught what, t. Okay, so that is what I'll get. Okay, so now if I have this one, then it's going to be equals to 1 over what, 2j into what, basically I'm going to have this one, okay, I'm going to have s plus j omega naught t, okay, minus, okay, s, okay, plus, okay, here let me bring bracket, j omega naught, okay, omega naught, sorry, here there's not supposed to be any t here, it's j omega naught, sorry, here there's not supposed to be any t here, it's j omega naught, all right. So j omega naught, okay, and then let me close this bracket, okay, here like this, okay. And then what am I going to have at the bottom here? Okay, so at the bottom here I'll have just as the other one, okay, this into this, s squared, this into this, negative, this into this, s squared, this into this, positive, this into this, negative, they will cancel each other, this into this, omega naught squared, okay. So here plus what, omega naught, sorry, omega naught what, squared, okay. So that is what I'm going to get. So now from here, see that this one and this one, they will cancel, okay. And then this one and this one, okay, it will be what, positive, okay, it will be positive. So I'm actually going to have here this one and then this one, okay. It's going to be what, positive, all right. It's going to be positive, okay. So now here I mean, they are going to add, they are going to, this time this is, they're going to cancel out, this time this, they are going to actually add for me. Okay, so here please, you see that this one This one will go into the denominator s plus j omega naught, s plus j omega naught. And this one will go into the denominator s minus j omega naught. Okay, so please here must be what? S minus j omega naught. S minus j omega naught. Okay, so let me write that part again. All right, it's what? 1 over what? 2j into what? S plus what? J omega what? Naught. Okay, minus here it will go into it s minus j omega naught, s minus j omega naught, okay, over what? S squared plus what? Omega squared. So this is equals to what? This will cancel this, okay, and then this will also become positive. So I'll have what? 2j omega naught over what? S squared, please here's omega naught, plus what? Omega naught squared. Okay, so this is what I'll get here. Okay, so now here, if I have this one, then I'll bring my what? 1 over 2j here. 1 over what? 2j. So 2j will cancel what? 2j. So if 2j cancels 2j, then what I can say is that sine omega naught what? T into u of what? T has a Laplace what? Transform of what? Omega naught over what? S squared plus what? Omega naught what? Squared. So that becomes the what? The Laplace transform for this one. And then what is the ROC? Okay, so the ROC is such that real of what? S is such that real of what? S. What is real of S? See that the function is what? T, u of t. The t is positive and t is equal to what? 0. So the signal is occurring at the what? Positive side of the what? Of the 0. So that means that the signal is what? Greater than what? 0. So real of S is greater than what? 0. Real of S is greater than 0. So this shall be the solution for this particular example. Thank you so much. See you in the next class.